Okay, I mean, I can see that there is not a lot of enthusiasm about these office hours. I will ask the class what would be the most convenient time that we can hold these office hours. We can do it on Thursdays later, or we can do it on Mondays. But I would like for us to be able to come here. Yes, go ahead.
Good evening, Professor. So I want to know when this meeting is being recorded, is there any way
Yes,
for us to watch it in the future?
yes, I always post it on YouTube, and I send a message to everybody that it's posted on YouTube.
Okay. So do you send it to us via email? Because I was looking for it and I couldn't find it.
I post it as an announcement, and
Okay.
it comes as an email, and so the link is there. If you did not see the last one, please remind me, and I will repost it.
Okay. Please do. Thank you.
Okay. All right. Thank you. I'm glad that you brought it up. Okay. Today, I'm going to talk about, I'm going to go back and repeat the lecture on standard deviation and the mean, and also how to use SPSS as a software to make it easy for you. You can always do it, the manual way, or you can use SPSS to do it. Like I said, if you do the assignment and do it correctly, uh, you will get 2 extra points on your final average. That is to say, if your average is 80, for each one that you assignment that you do by SPSS, you get 2 extra points. So if you do one assignment by SPSS, you will get 82 instead of 80. If you do two, you get 84. And if you do all 5 of them, you will get 90. So you can go from a B minus to an A minus just for practicing SPSS. Yes. Do you have another question?
I do. You answered the question about SPSS, but is there any way that we have access to SPS free besides actually coming into the school and using it in the school? Or do we have to
Um,
purchase it from IBM?
okay, one way to do it is to purchase it through IBM. The other way is over the years, we have had SPSS on campus. I suspect there's a way that the campus has SPSS, which is called the virtual desktop. But now that you bring up the question, we'll raise that question with the college if you can access it remotely. Again, send me an email to ask that question. I would appreciate it very much. Then I will call to find out if SPSS is available remotely for you. I mean, it
Okay.
should be, okay? It should be.
And
uh,
we don't, even though you are recommending that we get practice in using SPSS, we don't necessarily have to use it.
No, you don't, like I said, but
Okay.
if you do, you get 2 extra points
You get
added
extra
to
points.
your
I
average.
didn't hand in I didn't hand in the homework because I'm like, I was trying to figure out SPSS and I couldn't. So I was like, okay. So now I'm gonna do it in Excel and hand it in and then deal with SPSS separate to learn that.
Yes, yes, yes. You will not be able to figure out SPSS on your own unless you spend a lot of time doing it. Uh,
Oh,
yes, I mean, you can buy a manual, but it will take you a long time.
right.
Yeah. So I'm
Okay.
going to demonstrate it today.
Okay, thank
Um,
you.
okay. All right. And I've made it easy for you to use it. Okay. For example, I'm not going to, coach you on how to read data into SPSS. In the past, we used to do that, because it's very good. It enhances your skill when you go to the workplace. Uh, uh, for students who have gone to grad school, they have testified that it enabled them to succeed quicker more easily in grad school than if they did not know how to use SPSS. Because if you go to grad school, they are not going to even ask you if you know how to use it. They will give you the assignment in SPSS, and that's a problem. All right, so let me go back and provide some examples on how to um, calculate the mean and the standard deviation. But again, last week we did it, and like I said, I'm going to repost the lecture that we had last week, and then I'm going to do it again today. Uh, as we said last week, the mean is a measure of central tendency, and the mean is simply an average. So in statistical analysis, we have the population mean, we have the sample mean. So today we're just going to focus on the sample mean. The population mean is not different from the sample mean. The formula, the sample standard deviation, the formula is just slightly different, but not something to make you work any harder. Okay. So let me pull up um, this is a PowerPoint slide. Okay. And I'm going to go quickly through the slideshow. Um, right. So we'll be able to calculate the arithmetic mean, the mode and the median, the weighted mean, which we did last time. Okay. As I said, the mean is simply a measure of, it's an average. Okay. That's just the technical statistical word for it. Okay. An average. Okay. We will not go through these other things like the quartiles. As I said, the arithmetic mean is the most widely used measure of location. Okay. And it's calculated by summing the values and dividing by the number of values. Okay. So, and we symbolize the mean by using the Greek letter mu. Okay. This Greek letter mu is the sum of the values divided by the number of observations. Okay. N is the number of observations, and X is a particular value. And the sigma that you see here, the symbol that you see here, is an indication of an operation of adding. Okay, the sum of. Okay, this summation here, this sign here, is simply means the sum of the values. Okay, so for example, says the Kia family owns 4 cars. The following is the current mileage on each of the cars. Okay. One has 56,000, 23,000, 42,000, 73,000. And so the mean is the summation of x over n, which is 56 plus 73 plus 23 plus 42 divided by 4, which is 48,500. So the average mileage on the cars is 48,500. Okay. Now, the difference between the population mean and the sample mean simply means that instead of looking at the entire population, you take a sampling from that population. And so we use X bar as a way to symbolize the sample mean. Again, the same formula, the summation of the values in the sample divided by the sample size. So this small n represents sample size. The large N represents the size of the population. Okay, once more, the summation x over n is 14 plus 15 plus 17 plus 16 plus 15 divided by 5, which is 15.4. So the sample mean is 15.4. As we progress in this class, you will learn the significance of the difference, the significance of looking at the sample mean and how we relate the sample mean to the population mean and how we use the sample mean to address the population mean. We'll find that out along the way. All right. What they're trying to say here, you see here, they talk about the property of the mean. If you sum the differences between the mean and each value, for example, you have values here of 3, 8, and 4, and the mean is 5. If you subtract the mean from each of these values, and add the differences, you get a 0. It's always so. It is never different. Okay? That is the sum of the x values from the mean. 3 minus 5, 8 minus 5, and 4 minus 5 will always be 0. If you do any calculation where the sum of these differences is not 0, then there's an error in the calculation. Now, the weighted mean, again, the weighted mean is simply the sum of each value times its weight. And that's very easy. I mean, this weight sometimes is called a frequency. How many times, for example, does the value x1 occur? How many times does the value x2 occur? So the number of times x1 occurs is W1. The number of times that x2 occurs is W2. And then you add the sum of the weights and divide this upper value by the sum of the lower value. And I'm going to use an actual example from a spreadsheet to illustrate that. Okay. Okay. I'm going to stop share this and pull up a spreadsheet. Okay. I'll pull up a spreadsheet and use the spreadsheet to illustrate what we just said. This is a set of spreadsheet values, and I'm going to use the age, this age value, to illustrate the point. Okay. All right. Are you still seeing my screen?
Yes, I am.
Are you seeing the new set of values that I selected?
Yes, I can see them.
Okay. You can see age 26, 24, 33, 45, 23.
Yes, I can see them.
Okay. All right. I'm going to make it bigger. Okay. You can see them bigger now.
Yes, I can.
Okay. So as we said earlier, the mean is the sum of values um, divided by the sample size. So here we have a sample. Just trying to make it easier for us to understand. Uh, okay. So we have all right. So how many values do we have in the sample? How many different values? Want to tell me?
I'm sorry, Professor, 1 second. 12 values.
Okay, so we have 12 different observations. So in that case, we can say that n equals 12. The sample size is 12. All right, so n is equal to 12. All right, so the mean, therefore, x bar, and I'm just going to say x bar, which we calculated, is equal to, and you can use the sum. You can sum. Let us do systematically. The sum of values is equals sum, and you can just pull this down. You see, the sum of the values is 12. You get it?
Yes, I get it.
Okay. And the mean, the sample mean, x bar. Okay. Let me just make it, because this is a lesson. So let's be deliberate and let's be patient. The sample mean is um, equal B14 over 12, which is the sample size. You get it? So the sample
Yes,
mean
I
is what? Is 34.33. Am I correct? Do you get that?
Yes, Professor, I understand.
So I'm going to highlight it. That is the sample mean. So we calculate it by, I think, simply taking the sum of values divided by n. Now, suppose that we have what we call a distribution instead of just straight values. Suppose we have a distribution. So let us say we call that distribution frequency, or the weights. Okay, and the weights, as you know, are symbolized as W in the calculation. So as W, so I'm going to, let us say that the 5 persons that were age 26, right? 5% age 26, 10% age 24, 15% age 33, 12%, 10, 14. I'm using arbitrary numbers here to make the illustration real. 30, 18, 15, 13. Okay. So how many persons do we have in this group? Okay. How many persons do we have in this group? And so we say, well, sum. So we have 176 persons in the group. Am I correct? So n equals 0.76. So that is what we're going to use. Okay. And it's equal to 176. That is the sample size. Okay. Now, we are not going to just sum these values any longer to get the sample mean. What we're going to do is we're going to uh, calculate the frequency times the value. So we have a column here we call W times X. Okay. W times X simply means the weight times the value. Okay. So we take plus B 2 star C2. So we multiply 26 by 5. And so the weight times value here is 130. We do that down the line. So for each value, we multiply times the number of observations. All right? Okay. So now we're going to get the sum. We're going to get the sum. So the sum of the weights times the value is 6299. Okay. And so now the mean, the sample mean is now going to be 2699 divided by 176, which is the total number of persons in this new group. Total number of persons in the new group. And so we say the sample mean is equal to D14 divided by C14, which is the number of people in the group. So now you can see that the average age is now 35.7898. So now this is what we call the sample mean. So the next thing then that we wanted to talk about, and let me just step back and say that, I intend to delay the progress of this class just to make sure that we get the fundamentals, okay? We get the fundamentals. We may pick a topic towards the end rather than not understand the fundamentals. So next week, I'm going to go and kind of like redo the homework assignment that uses the technique that we're learning here so as to be able to understand the lectures for the future. So here we have now a new mean. Okay, we have now a different mean. Okay. Now, in the interest of time, I'm going to focus on this mean today, so that next time I'm going to now go through the standard deviation so that I can illustrate it also using SPSS. Or maybe I can, I don't think I'll be able to do it and do justice to it. So I'm just going to focus on how to calculate the mean using SPSS, okay? In that way, and I'm also going to demonstrate how to do histograms using SPSS, because I want us to be able to do it. Like I said, it's up to you to do it, to use SPSS, or if you can't, fine and good. But doing it by hand is tedious, okay? Very tedious. All right. So let me now step up and try to illustrate on how to use SPSS. Oh, well, you know what? Let's calculate the standard deviation, okay? And then next time we will illustrate how to use the standard deviation, but we'll also do SPSS today very, very quickly, okay? Now, the standard deviation is a measure of how widely dispersed okay, the data is. The last time I, demonstrated to you, let us look at, say, two neighborhoods, and I demonstrated that, okay? And I'm going to demonstrate it and just like wipe it off. Now, let's look at neighborhood one. This is neighborhood one, and this is neighborhood two, all right? Now, neighborhood one has somebody with a zero income. I'm going to make this big. Okay. There are three individuals in each neighborhood. 1, 2, 3. Okay. This is 50. This is 100. This is 45. This is 50. This is 55. So what is the average in each neighborhood? Okay. It was average. Okay. So the average income in this neighborhood is 50. And the average income in the second neighborhood is also 50. But in which neighborhood do you see that income is more widely dispersed? Which neighborhood do you see a wider variation in income? Tell me. Hello, my friend. Are you still there?
I'm here, Professor.
Okay. Which of the two neighborhoods do you think that income is more widely dispersed? A greater variation in income between the individuals?
You said which one is more widely dispersed?
Yes. In which neighborhood do you have a wider variation of income?
Neighborhood 2,
Why neighborhood two? Okay, in which neighborhood do you think income is more evenly distributed?
neighborhood 2.
Neighborhood two. That's where
Yes,
income is more evenly distributed.
yes. So
But,
what
but
was?
neighborhood one is where income is more widely, the sense of
Oh, I get it. I get it.
there's a greater variation. Okay, you can see that in neighborhood one person is a pauper, one person is typical or it's average, and the other person is very rich. While in neighborhood one, the average income, the typical income is about the same between first person, the second person, and the third person. There is not much variation. All right. So this is why we calculate standard
Thank you for
deviation.
clearing that up for me.
Thank you so much. I appreciate that. Now, so this is why we calculate standard deviation in statistical analysis, because it gives us a measure of variation. And measures of variation are very, very important, and they are used in different ways. Okay. So I said they are used in, say, conflict resolution. They are used in addressing issues of, say, discrimination. They are used in credit analysis. Okay. So there are just so many, many uses. So we're going to calculate standard deviation here. And we know that in order to calculate standard deviation, you use, uh, 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 let me stop this. Uh, Let me pull up. All right, you can see my screen.
Yes, I can see it now.
Okay. Now, standard deviation, there is a population standard deviation, which is um, Okay. The population standard deviation is symbolized by the Greek letter sigma and squared. So this is the population variance. The population standard deviation is the square root of the variance. Okay, you can see population standard deviation is the square root of the population variance. In the same way, the um, sample standard deviation is the square root of the variance, and you can see again the population variance is the sum of the deviations from the mean. Okay? The sum of the deviations from the mean, which is to say you take each value, subtract it from the mean, and then square it, and you keep going until the end, and then you sum it and divide by sample size minus 1. Okay? And I'm going to illustrate that. Okay? And so the sample standard deviation is the square root of the sample variance. Okay? So let's now go to our spreadsheet and illustrate that. Okay, so let's do the simple one before we do the weighted one. Okay, we take x minus x bar, then we take x minus x bar to the power 2 power 2. Okay, so that is what we are going to use, but we must calculate x minus x bar first. So this is equals each value, which is b2 minus x bar, which is $b $2. Sorry, the mean is x b $15. So we are looking at 34.33 as what we subtract from. Okay, so we subtract 26 from 34.33. We subtract 24 from 34.33. Okay. That is what we get. And you can see that if you take the sum of those values, what do you get? 0. Do you remember we talked about that?
Yes, I remember.
Okay. So if we take the sum of each value um, subtracted from the mean, we're going to get 0. That is what's going to happen. And if you don't get that 0, that means something is wrong. So now we are going to square each value, okay, equals E2 to the power 2. Right? So we're going to square each value.
Can you show me that equation again?
Okay.
Morehouse office hours 7 p.m. at 6:15 p.m.
Okay. Okay, what formula you want me to show you? How I got this value? Okay.
No, I see it. You did E2 and you found the square root of E2 and you're about to do the same thing for everything else. I see it.
Yeah, that's correct. Okay. So we are together. So now, in order to calculate the standard deviation, the variance, Okay, we take the sum of these values, which we illustrated in the PowerPoint slide. We take the sum of these values and then divide by n minus 1. Okay, and here we had 12 values. So let us take the sum of those values. Okay. That is the sum of all these values. You can see sum F2 to F13, right? Okay. And then the sample standard deviation, the sample variance. Okay? The sample variance, I'm going to here call this variance. That is the sample variance is this sum divided by n minus 1, which is equals F14 over 12 minus 1. Right? So 12 minus 1 oh, F14, not F1. F14. Right. So the sample variance is 95.2. The sample variance is 95.2. And then the sample standard deviation, just say sample standard deviation, the sample standard deviation is equals the square root. Okay, the square root is to the power half. Okay, equals F15 to the power 0.5. The square root is to the power half. And so the sample standard deviation is
Where'd you get the 0.5 from?
the 0.5, the square root of any number is that number to the power 0.5. Okay? I think we learned that in basic algebra. Or you can use equals square root, SQRT, F15. Get it?
Yeah, I see.
All right. I hope you learned something new today.
I did. Thank you.
All right. The square root of any number is that number to the power 0.5. Okay. The square of the number is that number times to the power 2. All right. All right. So you can see that you get exactly the same number. All right. So let me illustrate quickly in the next 15 minutes, and I'm going to redo it next week. In the next 15 minutes, the how to do this with SPSS. Okay. So I'm going to label that sheet illustration so that when you access the my announcement and the YouTube, you will see you'll be able to use the spreadsheet to help yourself to understand this much better. All right. Now, in order to facilitate our learning of the SPSS, I have loaded an SPSS file in addition to the Excel file. If I forget, somebody should remind me, but I'll make a note for myself. Load SPSS file to ECON316. All right, so let us do this same problem using an SPSS file. Okay, this is what an SPSS file looks like. You have what you call the data view. what you call the data view. This data view shows you the data. Okay, shows you the data. And the SPSS file contains the names of variables. Okay, the weights, club staff, exercise, overall, years in, gender, typical, age, years, visits. So what do these things mean? What do these things mean? Very easy. If you come here, see where it says variable view. Have you seen that?
Yes, I see it.
Okay. If you click on variable view, it will tell you the name of the variable. Weights here is weight equipment. Now, the whole idea here is based on a survey, which we often do in business administration. We survey and say, how satisfied are you with the weight equipment? How satisfied are you with the club staff? How satisfied are you with the exercise equipment? What is your overall satisfaction? Okay, how many years have you been in the club? What is your gender? What is the typical number of visits per week? What is your age? Okay, so for today, I'm going to just illustrate for you how to use SPSS to calculate an average. Then next week, we're going to do that assignment in the class, and everybody will pick up on how to do it. Not only how to answer the questions, but also how to use SPSS to do it. So that is what we're going to do next week. Okay. So I'm going to delay everything. I'm going to delay the submissions, the deadlines, and everything so that we learn how to do this properly. Okay? So for today, I'm just going to show how to calculate age. The other thing that I'm going to show is how to do frequency. Okay? I'm going to, again, distribution, and club. Of visit. Okay. I remember many years ago when I taught this class in the lab, students were impressed with what SPSS can do. And one student said, boy, this is very powerful. And yet you will see it's very powerful. All right. Let us first of all look at the frequency distribution using SPSS, what we can do with it. Okay. To do any kind of analysis in SPSS, you start from analyze. You analyze. Can you see it?
Yes, I can see it.
Good. So answer me because I want to be sure that you are following. Okay. You click
Okay.
analyze. So you see where it says descriptive statistics.
I see it.
Then you hit frequencies.
Mm-hmm.
How satisfied are you with club staff? You click on it. See the arrow, you put it in.
Hour 7 p.m. It's 6:25 p.m.
See where it says gender. You push it in. I'm going to use those two, just those two. All right. And I'm going to say, okay, what do you see? You see, it gives you a table, right?
You just picked two variables. I guess it's still loading on my end. I can't see the table.
Oh, no, it's not, let me see, there's somebody taught me something about what do you call it? How to go from application to application. Um, I'm going to see how I can change it so that you can see what happened. I will. I can fix it. Please share. Do you see the new screen?
I see statistics, frequency table, staff club. Club staff and gender. So yes, I do see
Okay.
this.
All right. So now you can see that by doing what I did, I created this table. You see it?
Yes, I see it.
Okay. So I'm going to do something else um, to make things easier. Uh, all right. So what I'm going to do here, um, values and gender, I will create a gender table. One is female, two is male. Okay. I'm going to do the frequencies again. Analyze. Retrieve frequency, and I'm going to have gender. All right. Are you seeing the new results, or do I have to go and share again?
Yeah, I can't see the new result.
Okay. You can or you cannot?
I cannot.
Okay. All right. I'm going to. Now, do you see the new results?
Yes, I see them.
You can see male, female. You get it?
Yes. Can you scroll up because it's kind of like all the way at the bottom of my screen? Are you able to do that?
Yes, I scroll it up as much as I can. No.
Okay, this is perfect. I can see it.
You can see it now. Okay. All right. So you can see there are 368 females and 846 males in this sample. Because I went and labeled, I put values on the label. Okay.
Okay.
Okay. So in the file that I will load for the class, I'm going to label them fully so that you can see what the values 1, 2, 3, 4, and 5 mean. Instead of the original 1 and 2 for male and female, you now see that there's female, there is male. You get it?
Yes, I understand.
Okay. All right. So you have a frequency distribution. You can cut this. I'm going to copy it. I'll stop this share. Okay. I'll pull up a spreadsheet file. Right? So you can see what I pasted?
So you just copied and pasted it from SPSS
Yeah,
into Excel?
to Excel.
Okay.
Okay. All right. So I'm going to paste this. Okay. I will insert. Okay. Chart. Okay. Do you see the chart? Do you see the chart in the Excel file?
Yes, I can see the chart.
Okay. So I created a chart out of
Mm-hmm.
it. You can now cut this chart and paste it into an MS Word file. So it makes life easier for you rather than trying to create a frequency distribution and a chart from Excel. So much easier. All right.
I see.
Okay. And so the last time I actually created the table for you, but I want you to be able to create your own table. This is some giving extra points. I mean, somebody can go from a B minus and A minus. It's not easy to achieve, but you also acquire a new skill. Okay, a skill that you can go and say, I know how to do this. Even if at the minimum, you know how to read the results from SPSS, that makes a lot of difference. Believe you me, um, it makes a lot of difference in the job market if you have a skill that the other person doesn't have. In my native language, we have a proverb that says the difference between one uh, one physician and another physician is one root, because in those days medicines were made from roots or from herbs. And so what makes one physician greater than the other physician is the one herb or one root. And believe you me, it's true for all ages. What gives you an edge is that you have one root that one herb that the other person doesn't have, because this is what is needed. Okay, so I'm going to stop it here, and next week I'm going to spend time on SPSS and how to do the homework assignments that you have. All right, I'm going to move this chart to a different sheet, and I hope you can see it. So it's in a different sheet now. Do you see the different sheet?
Yes, I can see it.
Okay. So you can now go and label it and do whatever you have to do. All right. So I'm going to hold it here, and thank you for bringing up whether this is posted or not, because I will definitely post it. All right.
Yes.
Okay.
I was looking for the SPSS,
Okay.
and I was able to find that as a CUNY student we have access to it. I put the link in the chat.
Okay.
So I don't know if anybody, it's called a Porto. So we just sign in there and we have access to SPSS from that link.
Okay. What you need to do is send it to me by email so that I
Okay.
can post it for the class. Okay.
Okay.
All right. I really appreciate it. I really appreciate it. Thank you so much.
Thank you.
All right. Have a nice evening.
You as well.